Knowing that these two angles are equal to each other, we have proven that they are equal to each other. So if they are equal to each other, this is going to be an isosceles triangle. So this side is going to be equal to this side because this is a triangle, angles at the base are equal, so it is an isosceles triangle. Therefore, this side is equal to this side. So now we have here this side being equal to this side. Okay, we have that already. Okay. So now that we have it, let's do the following. As we draw this, in parallel, I mean this being parallel to this. I draw this being parallel to this. I drew it parallel. So this, as this is parallel to this, is going to be equal. So now we have this being equal to this. But look, also this one. So we are going to have also this one being equal. So we're going to have the four sides equal to each other. We already have the four sides. What are we going to do next? Having the four sides, we know that when we did this figure, okay, we're not gonna call square yet. When we built together this figure, we did it with a right angle here, because when we did it like this one equal to this one. We did a right angle right here, so we have this a right angle. So let's look here. When we have here two parallelograms. Okay, we have two parallelograms, and here we have a straight line falling upon the two parallelograms, making the interior angles equal to two right angles. As this one is a right angle, this one must be a right angle. So this one is a right angle. Okay, this is a right angle, this is a right angle. As the four sides are equal, this is a parallelogram. As this is a parallelogram, the opposite angles are equal. So I have this angle being equal to the opposite to this, and also this one being equal to opposite to this. So we have here the four right angles and the four sides being equal. As I have the four sides being equal and the four angles being right angles, this is a square. But look at it. This square is on the base, that is the first part of our random straight line. So, as this is the first part, this is the first square we wanted to find. Okay? So, the other one. Okay? Right here. We have, here we have a parallelogram. Okay? We have that this side is equal to this side because we did it equal and parallel. So now this side is parallel and equal to this one. I also have that this one is parallel to this one because this one, okay, this one I drew equal to this one. Great. And I have this equal to this. I have here this equal to this. This is a parallelogram, okay? So, this parallelogram is made by this side and this side. But take a look at it. This side is equal to this one, the blue one, because we did it equal. Therefore, as this side is equal, because when we drew this line, we totally made this whole line equal to this whole line. So this whole line is equal to this whole line. Therefore, if this part, the red one, is equal to this one, and this one is equal to this one, we have here a parallelogram made by these two parts. So, segments, these two segments, okay? So we have this parallelogram being made by these two segments of the straight line. Great. We're also going to have right here we are also going to have here, so sorry, I had to pause because I was running out of battery, but I'm back. So, what happens here? I have this whole straight line being equal to this whole straight line, okay? So, as this whole straight line is equal to this whole straight line, and this line is equal to this line is itself, this parallelogram is made by this side that is equal to this one, and this side that is itself. We are going to have a, here we are going to have a rectangle, okay? We're going to have here, and we are going to paint it so we can see it, okay? Here we are going to have a rectangle. Great. Rectangle made by this whole straight line. That was our given in the beginning, okay? Great. As we have it, let's see here. Let's prove that this is also a square made by this part of the straight line, because here we have already done the square on the first part, the first segment of the straight line. Now let's prove that this one is also the square on this segment. Okay, so how are you going to do this? We are going to do the same steps as we did here, as we used here, okay? We are going to do exactly the same thing. We are going to see that this is an isosceles triangle. The angles at the base are going to be equal to each other. The angles at the base are going to be equal to each other. We are going to prove and we are going to say this is a triangle. And okay, we know that this is a triangle because we're going to do the same things we did here. Knowing that this is a triangle, it has right angles. And to prove that this square is the square that is on this base, this base that is a segment of the straight line, we are going to see that as this is a parallelogram, the opposite sides are equal to each other. So this is the opposite side to this. As this is the opposite side to this, and this is equal to this being also a parallelogram because the sides are equal, and also a right angle because this is a square, okay? Being a square, this side is equal to this side. This side equal to this side, and this side equal to this side. These sides are equal because two things equal to the same thing are equal to each other. Two things equal to the same thing are equal to each other. Okay, great. We have that. Okay. So, having that, let's see that this is a parallelogram. Okay, we have that. Okay, so here we've proven that this square is on the same base that is our first segment. Okay, so as this being our first segment, this being the segment, we have found already here this square that is on the first segment, and this square that is on the second segment. Okay, we also have found the rectangle contained by the straight line, that is this one. But look at this one. This one we have here, can you see that we have our whole parallelogram? All the sides being equal to each other. We have a whole parallelogram right here. So, these two are the complements. We have seen that in another proposition. So these two are the complements. We know that the complements are equal to each other. So these two complements are equal to each other. That is to say that this complement twice is equal to this complement plus this complement. Okay. So here we've seen here this is square. We've proven this is square in the base that is the first segment, and also this one that is on the base of the second segment. We have these two being equal to each other. Okay. So look here, the whole square, the whole chunk here, okay, that is on this straight line is made by the 4 chunks over here. This plus this plus this plus this chunk. So, as this this is the square on the first segment and this is the square on the second segment, and these two are the complements equal to each other. I mean the two squares, the two rectangles, because these are rectangles because it's not just a normal parallelogram because they have right angles, because we know here that they are right, the angles are right. So these two are rectangles. So they are rectangles. So at the two rectangles are contained by this straight line. So we have this one contained by this straight line. So twice of this one, this plus this, is equal to the rectangle on the straight line, contained by this whole straight line. So look what we have here. What we wanted to prove in the beginning was that the square, the whole square that is contained by this straight line is equal to this this square on the first segment and this one on the second segment, this square, and also that the two rectangles contained by this straight line was going to be equal to the whole square contained by this initial given straight line. So here we've proven our proposition, and that was proposition 4 of book 2. Thank you very much.